Right, our final group of functional groups are molecules that are ones that contain what we call a carbonyl. So a carbonyl is a carbon double bonded to oxygen. And the reason we don't just say carbonyls and leave it at that is there's actually a lot of subgroups within carbonyls. And so we can start with the simplest carbonyl, which is known as an aldehyde. An aldehyde is a carbonyl that on one side has a hydrogen and on the other side has an R group. And here's some examples of those. On either end we have some fairly pleasant compounds to work with. Vanilla and cinnamaldehyde. And in the middle you can see the simplest possible aldehyde that we have, formaldehyde, which if you've ever worked with any sort of preserved biological specimens, oftentimes that's what they're stored in to preserve them. Ketones are closely related to aldehydes. Ketones are a carbonyl with two R groups. And you can have nice simple ones such as acetone. Acetone, which you may know is nail polish remover, but it turns out is what we use in the organic lab to wash most of our glassware. Carvone, which is responsible for spearmint flavor, and here you can also see methadone has a ketone as well. Carboxylic acids are carbonyls that have an R group on one side and an OH group on the other side. One of the simplest carboxylic acids we can see here is acetic acid. Whether you know it by name or not, I'm not sure, but it's a compound you know very well by smell. Acetic acid makes up about 5% of vinegar. And so when you smell vinegar, it's the acetic acid you're smelling. Valine is another amino acid. In fact, that's where the name amino acid comes from. Every amino acid has a carbon that has an R group, a hydrogen, an amine, and a carboxylic acid. And so that's where the name amino acid comes from. Amine, acid. The only thing that changes from one amino acid to another is the identity of this R group. And then finally on this page you may recognize some common painkillers, things like ibuprofen and aspirin. Two more groups to go. Esters. Esters are kind of like carboxylic acid. And in fact, up to that point, they're identical. The difference between a carboxylic acid and an ester is the second bond here on oxygen. In a carboxylic acid would be a hydrogen. In an ester, it's another R group. And so esters include such common things as, you need work at the dentist office, you get some Novocaine. And also ethyl butyrate, you can see again carbonyl, OR on one side, carbon on the other side. That's what gives you your pineapple fragrance, pineapple odor. In fact, esters are actually responsible for a lot of common odors, especially from fruits. So if you look at this chart, you can actually see a lot of examples. So on the one side we have the group that is on the left of the carbonyl, and up at the top you have the group that's on the right side, or that's attached to the oxygen. And you can see based on how many carbons you have on each side, you get many, many different familiar odors. We've got strawberry, coconut, we've got pineapple, bananas, apples, many, many different things. All of their odors, their smells, come from the ester that they have. Our final group are known as amides. And these are very much like esters. The difference between an amide and an ester is right here. In an ester, we have an oxygen attached to the carbonyl. In an amide, that becomes a nitrogen. Amides also very, very important biologically. In fact, amides are what keep proteins together. So here's an example. We've taken alanine and attached it to glycine. How do amino acids attach to each other to form proteins? Well, very simply, the amine group on one reacts with the carboxylic acid group on the one next to it, and they form an amide. And these are known in the case of proteins as peptide bonds, but it's these amide bonds that keep the proteins together. We can also see that a molecule like penicillin has an amide. In fact, it has two of them. And finally, DEET, which you may have used at some point as insect repellent, is another common example of an amide. So now you should get out the in-class exercise labeled functional groups. What you'll find on that sheet are a large number of functional groups to identify. There's about 7 or 8 molecules on that sheet, and so you just want to go through each molecule on there and label each of the functional groups that you find within those compounds.